Hello, good Alem. How are you today? Hope you're doing fine. So in this video, I'm gonna show you the last Newton's law, that is the third Newton's law. Okay. So the third Newton's law, it states that for every action, there is an equal and opposite reaction. So, for example, if our body A exerts a certain force, we represent this force A to B on body B. B also exerts a force that we represent by B to A on body A that is equal in magnitude, so how much, but opposite in direction. Okay, so for example, if A exerts a force of 10 newtons, B will exert the same force of 10 newtons, but in the opposite direction. These forces are the results of simultaneous and mutual interaction between two objects. So when I have an interaction between two objects, always I have a force in pairs. So I always have a pair of forces. A force pull or push between objects that results when they press or push on each other. And let's be more specific about contact force, okay? That are force a result from objects that touch each other. You can't touch without being touched. Let's say, for example, a person is standing on the floor. The person pushes down on the floor, so he's in contact with the floor. And why does it happen? Because there is the gravity force that's pushing down. But also the force push up, okay? So force always comes in pairs. And how do I say this force? The name of this force I call normal force. Is the force that the floor, in this case, is exerting on the person. So the force is always contrary to the gravity force. So here you can see an interaction force pairs because I have the normal force and the gravity force. So they are two, the same intensity in this case, but opposite direction. When two objects contact each other, this contact interaction results in a pair of force, one on each object, okay? I have this pair, but each force is going to be in a different object. This pair of force acts simultaneously on the two interacting objects. We used to say law of action and reaction, but it is not right anymore, okay? It's not accepted anymore. So the best way to say it is law of interaction force pairs. So it's not right to say action reaction, but yes, to say law of interaction force pairs. Let's do an example. Explain which pair of force act on a book that rests on a desk. So let's see a book, it's at rest on a desk. I have the book pushing down on the desk because of the force of gravity. And also have the desk pushes up on the book. And what's the name of this force? Normal force. Let's do another example. Explain which pair of force act when a bucket is whirled in a circle using a rope. So I have a bucket here and whirling this using a rope. Which force is acting here? So I have the bucket put left on the rope and the rope pulls right on the bucket. Okay, so I have a pair force. Each of them act on one object. So the bucket pulls left on the rope and the rope pulls right on the bucket. So we can also rewrite this law as for every reaction there is an equal and opposite reaction. And this force is a vector. It has a magnitude, so magnitude is the size, a value, a number, and a direction. Newton's third law describes the relative magnitude and direction of the two forces in each interaction force pair. Magnitude is the equal force for each object, but the direction are the opposite direction, okay? So even though I have the same force, they are in opposite direction. Let's do another example. Explain the pair force acting between the ball and the meat in this picture. If the force of the ball is 30 newtons, what's the force and direction of the force on the meat? So here I have the force on the ball is 30 newtons. The force on the ball is of equal strength and opposite direction as the force of the meat. So if I have this force as 30 newtons from right to left, that is going to be the force on the ball. What can we say about the opposite force? So the direction, the force on the meat will be left to right, and the magnitude will be 30 newtons. So according to Newton's third law, for every reaction, there is an equal and opposite reaction, or a force of pair of force. Let's do another example. A very massive bus moving at highway speed collides with an unsuspecting little bug. Which object, bus or bug, experience the greatest force? Which of them will have the greatest force? So here I have some options. The force on the bug is the greatest. The force on the bus is the greatest. The bug and bus experience the same amount of force in the same direction. So same direction, same amount of force. Or the bug and bus experience the same amount of force, but in the opposite direction. Or there is no force involved in this situation. So let's think about each of them. Is the bug that has the biggest force? According to the Newton's third law, for every force, I have an equal pair of the same amount of force, but different direction, opposite direction. So what is the correct answer? The bus and the bug experience the same amount of force, but opposite direction. Okay? Now the same example, but also now is asking me the greatest acceleration, not force, but acceleration. And you know that force is equal mass times acceleration. If you have a big mass, I'm gonna have a small acceleration, and the opposite is also true. So let's say both of them has the same force, but which one is gonna have the most acceleration? The bug. Why? The bug has the great acceleration because it has the smallest mass. So if I'm checking the same, if I'm having the same force, the object that has the smallest mass will have the greatest acceleration. So the force between interacting objects are equal. So the force are equal, but the accelerations will be different, will not necessarily be equal. The acceleration will be equal just if the two objects are exactly the same mass. One more. A rifle recoils when fired. The rifle pushes the bullet forward. The bullet pushes the rifle backwards. This is an interaction force pair. Which object, rifle or bullet, experience the greatest force? So just like the other one, who is gonna give the biggest force? The force on the rifle is the greatest. The bullet is the greatest. They have the same amount of force, but in opposite direction, they have the same amount of force in the same direction, or there is no force at all. So this letter E makes no sense, right? There is force, of course. But which one has the greatest? No one. They have the same amount of force, but with the opposite direction, same direction. Opposite direction, right? So the rifle and bullet experience the same amount of force in opposite direction. Now the same question. Which of them has the greatest acceleration? The bullet or the rifle? The bullet, why? We have the greatest acceleration because it has the smallest mass, okay? Okay, so in summary, force results from interaction between two objects, and this force interaction always comes in pairs. So I always have a pair of force acting between two objects. The magnitude of the force is always equal, but the force, the direction is opposite, okay? So the magnitude of the force is the same in both objects, but the direction are opposite. And the force is called acceleration, and acceleration will be the greatest for the least massive object. So the smallest object we have more acceleration, and the biggest object we have less acceleration. They only have the same acceleration if both mass are exactly the same, okay? So that's it. I hope you have enjoyed, and thanks so much for watching.